Good morning, students. I am Katyani, lecturer in Electronics and Communication, Department of Collegiate and Technical Education. Today, I will start with the third session of Unit 2, Instruction Set and Assembly Programming of 8051. The course is Microcontroller and its Applications of third semester diploma. The course code is 15MC34T. The program is Mechatronics. So let us have a quick discussion on what we have discussed in the previous session, that is session 2. So in session 2, we have discussed what are addressing modes and what are the types of addressing modes. So what are addressing modes? The different ways of accessing the data is known as addressing modes. So the different addressing modes that are listed here is immediate. The first one is immediate addressing mode. In case of immediate addressing mode, the immediate data is specified as the part of the instruction. So consider this example, move R0, immediate data, that is 08H. This data will be copied into R0. So this hash symbol indicates the immediate addressing mode. The next is register addressing mode. In case of register addressing mode, registers are specified as a part of the instructions. Example, move A, R4, where the contents of R4 will be copied into accumulator. So here the registers can be R0 to R7. There are around 32 general purpose registers R0 to R7, each distributed into each register banks. There are 4 register banks. So each register banks consists of 8 general purpose registers. So totally there are 32 general purpose registers. Next is direct addressing mode. In case of direct addressing mode, the direct address is specified as a part of instruction. That is nothing but RAM location from 00H to 7FH or SFR location from 80H to FFH. So RAM location 0 to 7FH can be specified here. So here this is the RAM location 50H. So this is the memory location where actual data is present. So that data will be moved into accumulator. So this is direct addressing mode. Next is indirect addressing mode. In case of indirect addressing mode, the registers will be used as pointers for the memory location where actual data is present. For example, so we have taken move A, at R0. So R0 will have a data that is nothing but memory location where the actual data that is to be used is present. So these are memory pointers. At indicates that it is a memory pointer. The pointers can be either R0 register or R1 registers. So the contents of memory location pointed by register R0 will be copied into accumulator. The next addressing mode is indexed addressing mode. So in case of indexed addressing mode, so here the effective address will be calculated, which is nothing but the sum of offset plus base. So here we can see, so sum of this is the offset, A has the offset and DPTR has the base. So these two addresses will be added to calculate the effective address. At indicates that it is a pointer to a memory location. So the effective address will be calculated and the contents of that effective address will be copied into accumulator. Next is relative addressing mode. In case of relative addressing mode, we can have a jump or a call to another location within minus 128 to plus 127. So it can have a short jump within the range of minus 128 to plus 127. Next is absolute addressing mode. In case of absolute addressing mode, it is similar to relative addressing mode where the jump can be extended till 2 kilobytes. Next is long addressing mode. Long addressing mode is also similar to relative or absolute addressing mode, but where the jump or cal can be made within entire 64 kilobytes of memory space. Next is inherent addressing mode. In case of inherent addressing mode, the data usually it is used for accumulator, and this data will be updated and stored in the same accumulator register. Say for example swap A, where it will swap the higher nibble with the lower nibble and lower nibble with the higher nibble, and the contents will be stored in accumulator itself. Such type of addressing modes are called inherent addressing mode. Next is bit inherent addressing mode. So in case of bit inherent addressing mode, the contents of flags will be implied there itself. Say for example, say here clear carry. The carry will be cleared and updated in carry itself, carry flag itself. So that is bit inherent addressing mode. Next is bit direct addressing mode. In case of bit direct addressing mode, the bit addressable memory, that is 20H to 2FH of 8051 RAM, will be specified as a part of the instruction. That is bit location 06H. Here set bit, it sets the bit location 06H of bit addressable memory. Next, so these are the contents that we will be discussing in this session. One is assembly language instruction format, that is not set, it is format. Next is assembler directives. So what are assembler directives? And we will be discussing or a few of the assembler directives, that is origin, DB define byte, next define word, next equate, and then end. Next we will discuss what are assemblers, linkers, loaders, and cross compilers. These are the things I will be covering in this session. So this is the assembly language instruction format. So assembly language instruction format consists of three fields. One is label field, followed by instruction field, followed by comment fields. So this label field is defined by the programmer and it is optional field. So this label field specifies the address of a location, or it may be a statement in the points to a statement, instruction in a statement of a program. So this label field is always optional. If at all the user wants to use this label field, then he has to write the label followed by a colon symbol. The next field of assembly language instruction format is instructions field. The instructions fields consists of two fields. One is opcode field, another one is label field. So this instruction field is very important field in case of 8051 assembly language programming, because it specifies what has to be performed. So it is divided into two fields. One is opcode. Opcode is very important field because it specifies what operation has to be performed. So opcode is nothing but operation code. What operation to be performed is specified by the opcode field. Opcode field is followed by operands fields. Operands fields specifies the data, that is data on which the operations has to be performed. Operand specifies the data on which operations has to be performed. So this operands field has two types. One is source operand and next is destination operand. The source operand is where the data will be used, and the destination operand is where the data will be updated, that is results will be updated. Next, operands field is followed by the comments field. The comments field are defined by the programmer and or a developer. So here the comments are helpful in easy understanding of the program, and they are also helpful in proper documentation of the programs. So these are not the mandatory fields. Comments fields are not the mandatory fields, and if at all a programmer has to use a comments field, then he should start with a semicolon or a double slash based on the compiler that he is assembler that is using. Let us take an example of assembly language instruction. So here in this instruction, L1 indicates the label. So this label is followed by colon, and next is the instruction, move is the opcode, and A and 34H are the operands. So this is a direct addressing mode where 34 is the RAM location where it has the actual data that has to be used for operation. What is the operation that is performed? Move. Move means it copies the contents of memory location. Contents of memory location, that is 34 will have a memory location. Inside that we have the contents. That contents will be copied into accumulator. Next, this instruction is followed by a semicolon uh, because it starts with a comments. So these comments are optional fields which indicates used for easy understanding of program. The contents of RAM location 34H is copied into accumulator. So this is the comment. It indicates for proper understanding of the program. Next, assembler directives. What are assembler directives? Assembler directives are not the instructions to the microcontroller or a CPU. So these are the instructions for the assembler during the process of assembling, and they indicate what operation to be performed during assembling. And these are pseudo instructions. These assembler directives are not converted into machine language during the process of assembling. So assembler directives are pseudo instructions, and these are instructions to the assembler during the process of assembling and not to the CPU. And these are the few assembler directives that we will be discussing in this session. One is org origin, next is define byte db, define word dw, equate equ, and end. So org, that is set origin. So usually the 8051 microcontroller will start executing the code from program memory at the address 000H usually. And assembly language program will start assembling from the program memory address 000H. If at all the user want to change the order where the program or data anywhere in the different address space of a microcontroller, then they will go with origin. Say for example, org 000DH. So this tells the assembler to assemble the next statement at 000DH. So that is to start from this memory location. Start the assembling process from this memory location. Next is define byte directive. Define byte directive is used to define a byte type variable. Using this directive, you can define data in decimal, binary, hexa, or ASCII formats. So here data 1. So this is the memory location, that is label. Here db is defined byte 10. 10 is the decimal value. So it defines a byte with 10. Data 2 defined byte 30H. So here 30H, it indicates that it is a hexadecimal number and a byte will be defined with value 30H. Data 3 is the memory, that is memory location, that is a label. db defined byte, it defines a string. Strings in 8051 can have single quotations or double quotations. So data 4 colon db, so here defined byte, so this is a binary number. So B indicates the values are in binary. Next the data is db 1234H. So here since db is defined byte, so here we are giving 16-bit value. So hence only lower bytes will be considered, that is 34H will be considered. The next directive is define word. The define byte directive is used to include a 16-bit data in a program, whereas define byte is used to specify 8-bit data, whereas this is for 16-bit data. This is similar to your define byte. So define word, example define word 1234H. This is a 16-bit data and its value is in hexadecimal. Next is equate directive. The equate directive helps us to keep a symbol with a value or a label with a value. So usually it will have a label. So the label will be replaced with the value. So every occurrence of label will be replaced with the value. For example, count equate hash 30. So this is count is the label field, followed by equate is the directive, and immediate 30. So whenever count occurs, that value will be replaced by 30. Next, red underscore LED equate port 1.0. For every occurrence of red LED will be replaced with port 1.0. That is label, every occurrence of label will be replaced with a value. This is equate directive. This reduces the time. So it speeds up the processor. Equate directive helps to speeds up the processor. Next, end. The end directive is used to stop the assembling process. This should be the last statement in the program. The statements after the end directive will not be used for the process of assembling. So in any 8051 program, end is the last statement and the statements after end directive will be ignored for the process of assembling. Now let us discuss what is the difference between assembler directives and instructions. What are assembler directives? So assembler directives are pseudo opcodes. So whereas instructions they are true opcodes because they are converted into machine language, but assembler directives are not converted into machine language. Hence they are pseudo opcodes. Next difference is that they do not generate any machine code during assembling process. Assembler directives do not generate any machine code during assembling process, whereas instructions they translate into machine language by assembler. They require an assembler to convert the assembly level language into machine level language. The next difference is these are the instructions to the assembler. Assembler directives are the instructions to the assembler at the assembling time. So instructions are for CPU at the runtime. The next difference is the directives are different for different assembler. The assembler directives are different for different assembler, that is assembler specific. Whereas the instructions remains the same for a particular microprocessor or a microcontroller irrespective of the assembler. The example of assembler directives are we have discussed a few of the assembler directives: origin, equate, end. So these are the assembler directives. And instructions, example of instructions, we have discussed few instructions like move or not comma a, add a comma at or not, mul ab. So these are the examples of the instructions. Next we will discuss what are assemblers, linkers, loaders and cross compilers. What is an assembler? Assembler is a program that converts assembly level language into machine level language. What is a linker? A linker is a tool that is used to link all parts of the program together for execution. So the linker will link all parts of the program together for execution. Usually the hex file is used. The linker generates the hex file. Next, the loader. A loader loads all these files into memory and then the program is executed. Usually the hex file is given for the loader in order to form a operation, that is it will load the files into the device for execution. A cross compiler is a compiler capable of creating executable code for a platform other than the one for which the compiler is running. A cross compiler is a compiler capable of creating executable code for a platform other than the one on which the compiler is running. For example, the compiler that runs on Windows 7 PC but generates codes that runs on Android smartphone is a cross compiler. So what is an assembler? An assembler is a program that converts assembly level language into machine level language. The linker tool is used to link all parts of the program together for execution. It generates an executable code that can be given for the loader. Usually .hex files will be given for the loaders. A loader loads the files into memory and then the program is executed. For the proper execution of the program, the file has to be, hex file has to be loaded to the loaders. Next, a cross compiler is a compiler capable of creating executable code for a platform other than the one on which the compiler is running. So these are the session highlights. So what have we discussed in this session? The assembly language instruction format. The assembly language instruction format has three fields. One is label field, followed by instructions, and then comments. Label and comments are optional and instructions is mandatory fields. Out of instructions, opcode is a mandatory field. Next is assembler directives. So assembler directives are actually instructions to the assembler and directs the assembler program what to do during the process of assembly. So we have discussed few assembler directives. One is origin. It sets the origin. It tells the assembler to assemble at particular memory location. Next is define byte. It defines a byte type of variable. Equate. For every occurrence of the label, it will be replaced with a value. Next, end. The end directive is used to stop the assembling process. And we have also discussed what are the difference between assembler directives and instructions. And we have also discussed what is an assembler. An assembler is a program that converts the assembly language into machine level language. A linker is a tool that is used to link all parts of the program together for execution. A loader loads all the files into memory and then the program is executed. A cross compiler is a compiler capable of creating executable code for a platform other than the one on which the compiler is running. Coming to the MCQs of session 3, multiple choice questions of session 3. First one, assembly language instruction consists of first one opcode, second one operands, third one label. Select the correct solution using the codes given below. Option A 1 only, option B 2 only, option C 1 and 3 only, option D 1, 2 and 3. Assembly language instruction consists of, yes, it consists of all the three fields opcode, operands and label. But the mandatory field is opcode field. So correct answer is option D. Next question. Following fields are optional in assembly language instruction. First one opcode, second one comments, third one label. Select the correct solution using the codes given below. Option A 1 only, option B 1 and 2 only, option C 2 and 3 only, option D 1, 2 and 3. What are the optional fields in assembly language instruction? Yes, optional fields are comment fields and label fields. So what is the correct answer? Correct answer is option C, where it has 2 and 3 only, comments and label. So these are the optional fields. Third question, the data on which the operation is performed is represented as option A operands, option B opcode, option C mnemonics, option D none of the above. The data on which the operation is performed is represented as, yes, the data on which operation is performed is operands. It is option A. Fourth one, statements included by the developer for easier understanding of the code is option A mnemonics, option B comments, option C opcode, option D none of the above. Statements included by the developer for easier understanding of the code is, what are the statements that are included for easier understanding? Yes, it is comments, option B. Fifth one, comments in 8051 assembly language programming can be begin with a first option semicolon, second option double slash, third option slash star. Fourth option ash. Select the correct answer using the code given below. Option A 1 only, option B 2 only, option C 1 or 2 only depending on assembler, option D 1, 2 and 3. Tell me comments begin with? Yes, the comments begin with either a semicolon or a double slash depending on the assembler. So correct answer is option C. Sixth one. Assembly language directives are actually instructions to option A compiler, option B assembler, option C CPU, option D none of the above. Assembly language directives are actually instructions to? Yes, it is assembler. These are the instructions to the assembler. So it is option B. Seventh one. The directive that directs the assembler to start the memory allotment for a particular segment or a block or a code from the declared address is option A equate, option B label, option C origin, option D define byte. The directive that directs the assembler to start the memory allotment, which one? Yes, it is origin. That is option C. Eighth one. The directive that marks the end of an assembly language program is option A ends, option B end, option C ends and end, option D none of the above. The directive that marks the end of an assembly language program. Yes, it is option B end. Ninth one. The recurrence of the numerical values or constants in a program code is reduced by option A assume, option B local, option C label, option D equate. The recurrence of numerical values or constants in a program code is reduced by? Yes, which avoids the recurrence of a numerical values? Yes, it is equate, option D. 10th one. Assembler directives are first one pseudo instructions, second one are not converted into machine language during assembling process, third one instructions to CPU at the runtime. Select the correct answer using the code given below. Option A 1 only, option B 3 only, option C 1 and 2 only, option D 1, 2 and 3. So assembler directives are? Yes, they are pseudo instructions. First one. Second one, are not converted into machine language. Yes, this is also a correct statement. Instruction to CPU at the runtime. Are assembler directives instructions to CPU at the runtime? No. So what is the correct answer? 1 and 2. It is option C. Pseudo instructions and are not converted into machine language during assembling process. So assembler directives are pseudo instructions and are not converted into machine language during assembling process. So answer is option C. These are the solutions for the MCQs. Thank you.